Hello, welcome back. This is just actually a quick video for chapter 5.5. This lesson is all about graphing the trig functions, particularly sine and cosine, and some things about them. So if you look at the values of t, or the angles in radian, and these are the values, the ratio values of sine at those radian measures. We can then put them on a graph here and see the cycle or the waves that sine creates. So, the graph of sine from 0 to 2x starts at 0, goes up to 1, back to 0, down to 1, and then back to 0. So it makes this cyclical pattern here. And this is what cosine looks like. Cosine is the opposite. It starts at 1, goes down to 0, down to -1, up to 0, back to 1. So some properties of sine and cosine that are important to know is that if for sine of x plus any 2 pi, so coterminal values, is equal to sine of x, and the cosine of x, or coterminal values, is equal to the cosine of x. The function is said to go through one cycle between every pair of repetitions. The domain of sine and cosine are all real numbers, and the range of sine and cosine goes down as low as -1 for each and up to a +1. So the sine and cosine both oscillate from -1 to 1 in different cycles, and that's called the amplitude. The amplitude is the height from the x-axis up, and so it goes from 1, it goes up to 1, and then down to 0, and then down to a -1, and back to 0. There are other pieces, characteristics that we're going to learn too. So the amplitude is the absolute value of A, which is the coefficient out in front of the function. Usually it's just 1. The period is how long it takes to cycle through. So that's 2 pi divided by b. So b is the coefficient on x on the inside. The graphs of these functions are found by applying the following transformations to the graphs of the functions of just sine x and cosine x. So there could be a horizontal stretch, which would be 1 over b. There could be a horizontal compression, would be 1 over b if b is greater than 1. There could be a vertical stretch, which is the absolute value of a, if a is if the absolute value of a is greater than 1, or a vertical compression if the absolute value of a is less than 1. There could be a reflection across the x-axis if a is less than 0. There could be a horizontal shift, so a left and right shift of c, as we've seen in other functions this semester, x minus or plus c. And then there could be a vertical shift, an up and down shift afterward. So, for example, 1, it says, find the amplitude and period of this function here. So the amplitude is equal to the absolute value of a, which is just the absolute value of a -1. So the amplitude is 1 for this function, because a is a -1 in this case. And then the period of this function is 2b divided by b, 2 pi divided by b, where b is equal to 1/2. So 2 pi divided by 1 over 2 is equal to 4 pi. So the period of this function is 4 pi. And example 2 says the frequency of a sine function is given by 1 over p, where p is the period. find the frequency of an AM radio station whose waveform is given by this function here. A times the sine of 1.2 times 10 to the 6 pi t, where A is some positive constant. So we need to find P is the period, is equal to 2 pi over B, which in this case is 2 pi over, and this is B. 1.2 times 10 to the 6th pi. So the pi's cancel, and we have 2 over 1.2 times 10 to the 6th. And so I'm going to put this into Desmos. And so 2 divided by 1.2 times, no, times 10 to the 1 point, oh no, 10 to the 6. Okay. And so this is extremely small, 0.00005 zeros, 167, but it's the reciprocal of this because the frequency is equal to 1 over that. So it's really the reciprocal. So it's 1.2 times 10 to the 6 divided by 2. 1.2 10 to the 6. Divided by 2. So it's really 600,000. And I'm going to show you what that looks like on paper. 600,000, or we can say that that's 6 times 10 to the 5th hertz is the measurement for radio frequency. That's fun. Catch me back for the next video.